In this video, we are going to solve a functional equation. F of x plus 3 divided by x minus 3 is equal to x squared plus 6x plus 9 divided by 12x. We have to find a function f of x. Notice that in a problem like this one, we are not solving an equation. We don't have that this is equal to some constant c or something else. So we are not looking for a specific value of x. For a problem like this one, we are looking for a general formula for a function f that is in terms of a variable x. In this case, an input of our function is a complicated expression x plus 3 divided by x minus 3. And this is what solving functional equations is all about. A pattern for solving problems of this type is to introduce a substitution which replaces this entire complicated expression in an argument of function f. In our case, this x plus 3 divided by x minus 3 with a single letter variable, and let's call that t. The idea that we have is to replace this entire argument of a function f with t. So we are looking for f of t now. And we are trying to find that value. Now that we are interested in finding the value of f of t, and in the argument you can observe that there is no variable x, we have t, our job is to replace x from all its appearances on the right side of the equation with a variable t. Effectively, we are looking for a transition from variable x to variable t. We have our substitution, t is x plus 3 divided by x minus 3, and from here we are going to isolate x. And thus we are going to find the connection from variable x in respect of variable t. So we are looking for x in terms of t. This is going to be simply done with some algebra. So we have that t is equal to x plus 3 divided by x minus 3. We can multiply this entire equation by x minus 3, and then it becomes tx minus 3 is equal to x plus 3. Tx minus 3t is x plus 3 after the expansion. And now put everything that has x on one side, on the left side of the equation, and everything else we are going to put on the opposite side of the equation, the right side in this case. So tx minus x is equal to 3 plus 3t. So x is in common and we have t minus 1, and that is equal to 3 plus 3t. So we have that x is equal to 3 plus 3t divided by t minus 1. And as you can see, this is x in terms of t. So x in terms of t is equal to 3 plus 3t divided by t minus 1. And that is one part that we need. Let's observe the starting problem. We have f of x plus 3 divided by x minus 3, and we know that that entire part is equal to t after our substitution. So we effectively have f of t. F is taking the argument of t. What do we have on the right side of the equation? We have x squared plus 6x plus 9 divided by 12x. And here we are going to plug in the expression for x in terms of t. This expression right here. We can make things simpler for ourselves. because we have x squared plus 6x plus 9 divided by 12x, we can observe that this is x squared plus 2 multiplied by 3x plus 3 squared divided by 12x, and this is just x plus 3 squared divided by 12x. So let's use this fact. F of t then becomes 3 plus 3t divided by t minus 1 plus 3 squared divided by 12 multiplied by 3 plus 3t divided by t minus 1. And from this position, we are going to simplify everything that we have on the right side of the equation to find f of t. So we can take that f of t is equal to a fraction. In the numerator, we have 3 as common, so we have t plus 1 divided by t minus 1, and plus 3 squared divided by 12 multiplied by 3t plus 1 divided by t minus 1. We are going to focus on the numerator. We have two terms here that are being added, so let's put them over a common denominator. So this is 3t plus 1 divided by t minus 1 plus 3t minus 1 divided by t minus 1, and that entire part is going to be squared over 36t plus 1 divided by t minus 1. And then this is equal to 3t plus 1 plus 3t minus 1 over the same denominator t minus 1 squared divided by 36t plus 1 divided by t minus 1. So this is 3t plus 3 plus 3t minus 3 divided by t minus 1 squared divided by 36t plus 1 divided by t minus 1, and 3 are going to cancel out. So we have 36t squared, 3t plus 3t, that is 6t squared, 36t squared, divided by t minus 1 square, divided by 36t plus 1 divided by t minus 1. And that is equal to. When you have to divide by fraction, the simplest method is to flip the denominator and then multiply. So that is 36t squared divided by t minus 1 squared. That is a numerator. We are going to multiply it by flipped denominator, t minus 1 divided by 36t plus 1. T minus 1 squared is going to cancel out with t minus 1, and 36 is going to cancel out with 36. So we have that this is t squared divided by t minus 1 multiplied by t plus 1, which is just t squared divided by t squared minus 1. We can play with this a little bit to write this in a nicer form by subtracting 1 and then adding 1 in the numerator. So t squared minus 1 plus 1 divided by t squared minus 1, well, that is equal to t squared minus 1 divided by t squared minus 1 plus 1 divided by t squared minus 1, and that is 1 plus 1 over t squared minus 1. You can make this step, you don't have to, you can finish here. So we finally have that f of t is equal to 1 plus 1 over t squared minus 1. Our job was to find f of x, and we have f of t. We can treat variable t like a placeholder variable and just replace all of its appearances with x. And by doing that, we get that f of x is 1 plus 1 over x squared minus 1. And if you took the other route, you will get that f of x is equal, from this position, x squared divided by x squared minus 1. It's the same thing. Of course, this is then going to be the final solution of our problem. Of course, this video is not over yet. I have to deliver the punchline because of which I am filming this video. So the question that we now have is, how do we know that this formula for f of x is correct? Well, we can verify this by just plugging in the value of x plus 3 divided by x minus 3 instead of x into that formula that we have. So f of x was 1 plus 1 divided by x squared minus 1. So let's do that. F of x plus 3 divided by x minus 3 is equal to 1 plus 1 over x plus 3 divided by x minus 3 squared minus 1. And this is equal to 1 plus 1 over x squared plus 6x plus 9 divided by x squared minus 6x plus 9 minus 1. And that is equal to 1 plus 1 over x squared plus 6x plus 9 divided by x squared minus 6x plus 9 minus x squared minus 6x plus 9 divided by the same thing. So this is equal to 1 plus 1 over x squared plus 6x plus 9 minus x squared plus 6x minus 9 divided by x squared minus 6x plus 9, which x squared and negative x squared and 9 and negative 9 are going to cancel out. And we have 1 plus 1 over 12x over x squared minus 6x plus 9, which is finally 1 plus x squared minus 6x plus 9 divided by 12x. And that is 12x plus x squared minus 6x plus 9 divided by 12x. So we get that f of x plus 3 divided by x minus 3 is x squared plus 6x plus 9 divided by 12x, which is exactly what we needed. I want to bring your attention to one stupid mistake that I see students make when dealing with problems like this one. And in fact, it's not just students, but also my fellow YouTubers in math space. I have noticed that they use the following method for verifying the correctness of the solution. They pick a number, let's say number 4, and then they plug it in the equation to see if they get the same values. So f of x plus 3 divided by x minus 3 is equal to x plus 3 squared divided by 12x. For x is equal to 4, when we plug this into the function f, we get that f of 4 plus 3, 7, divided by 4 minus 3, 1, is equal to 4 plus 3, 7 squared, divided by 12 multiplied by 7. So we get that f of 7 is equal to 49 over 48. And on the other side, for x is equal to number 7, in the solution which we get that f of x is x squared divided by x squared minus 1, we get that f of 7 is equal to 7 squared divided by 7 squared minus 1, and we get 49 over 48. And because that both of these numbers are equal, they draw the conclusion that these functions are the same. So the solution is correct. And that logic is just flawed. You see, these functions here have infinitely many numbers in their domains. So in order for them to be equal, they have to give the equal results for all the numbers in their domains. When there are infinitely many numbers, you can't check for all of them, which checking for all of them is exactly what you have to do. And to illustrate this, I want to give you this simple example. Let's observe two functions. Function f, which is defined for the values 1 and 2 in its domain, and the image of number 1 is 3, the image of number 2 is 4. And let's observe the second function g, which is defined also for numbers 1 and 2, but it takes the image 4 for both of these numbers. If we follow the method for number 2 in the domain, we get that f of 2 is equal to 4, and that is equal to g of 2, and then f is the same function as function g. So this is the method, the logic, which is used by many students and my fellow YouTube creators, and that is just wrong. This is a contradiction. Why? Because there exists this number 1, that f of 1 is equal to 3, and g of 1 is equal to 4. So we clearly have that f of 1 is different from g of 1, and that means that f and g are not the same function. They are completely different. So this is true logic. You can take one specific value to prove that two functions are different. But if you want to prove that functions are the same, well, you have to prove that they are the same for every number in their domain. In this case, that is not hard to do. But in the previous case, when we had the functions which had infinitely many numbers in the domain, that approach is impossible. So in order for two functions to be the same, functions f and g are the same if and only if they have the same domain. The domain of function f is the same as the domain of the function g. Their codomains have to be the same. Codomain of function f is the same as codomain of function g, and for every value from the domain, any domain, f or g, because they are the same, f of x has to be equal to g of x. So in order for functions f and g to be equal, the conjunction of these three terms has to hold. Now, I want to show you how important this is, because many students make an error when they are trying to do this. So let me broaden the story just by one more example. Let's take a look at function f, which is defined with f of x is equal to x, and function g, which is defined as g of x is x squared over x. The question is, are these two functions the same? Well, f of x is equal to x, and g of x is x squared over x. We can cancel out x, and then we get that g of x is equal to x. So the conclusion is that f and g are one and the same function. That's wrong. Why? Because of this here domain. So, the domain of function f is an entire set of real numbers. What is the domain of the function g? Well, that is an entire set of real numbers except number 0. Why? You have x squared over x. So if x is equal to 0, g of 0 is equal to 0 squared divided by 0. What is something divided by 0? Well, that is not defined. So you have a problem. Number 0 does not belong in the domain of this function g. So simply, functions f and g have different domains. So as domain of function f is different from the domain of function g, that means that functions f and g are not the same. So please, for the love of God, stop using this stupid method. And on that bombshell, I want to end this video. So thank you for watching, and I'll see you in the next one.